So welcome to 0.2. So these lessons are in Unit 0 to begin the year because they're review. They're the kind of thing you need to know so that you can succeed this year, but you should have already learned all of this in 6th and 7th grade. So I'm expecting everyone can already do this. See if you can. So when we add negative 11 to negative 9, right, if you just add them up and you get negative 20. 11 negatives plus 9 negatives equal 20 negatives, right? Two negatives do not make a positive. That's a multiplying rule, not an adding rule. And so the way I like to talk about this is if you owe $11 to one person, you owe $9 to another person, you owe a total of $20. And one thing I talk to my 7th and 8th graders about is that I'd like to talk of negatives, meaning you owe as owing money. So you'd owe 20. The second one is different, right? We have 7 positives here. And now hopefully you're an algebra student, you don't have to draw these anymore. But we have 7 positives and we have 8 negatives, right? And 7 positives plus 7 negatives would make 0. So 7 positives plus 8 negatives make negative 1. In the last one, we have, or the third one, we have 6 negatives, and we're adding. That's not a positive symbol, that's an adding symbol, right? And then we don't write the positive symbol on 2, which leads to some confusion in some students. But that's a positive 2. And 6 negatives plus 2 positives is clearly negative 4, right? Because 2 negatives plus 2 positives would be 0. And so the answer to that is negative 4. So that is problems with integers. Integers is the math word for positive and negative whole numbers, right? Not fractions, not decimals. So let's go over it with decimals here. So let's first look at the one above it. It's very similar, right? The one above it, we had 11 negatives and 9 negatives and got 20 negatives. Now we have 11.2 negatives and 9 negatives. And if I can't do it in my head, I'm going to come over here and line up my decimal points and realize that I have negative 20.2 or 20 and 2/10 negatives. Okay. Now in my class this year, you're allowed to say that as 0.2. You're also allowed to say it as 2/10, as I'm sure some of your teachers made you say it last year. Either is fine with me. Okay. The next one, we have 7, the one above it, when we had 7 positives plus 8 negatives, we got negative 1. So we better get an answer around like that. So we're canceling here. I don't like to say it as subtraction, but it is, in fact, when you do this, you're going to be subtracting. But you get 1.3 here, but it's not 1.3. It's negative 1.3 or negative 1 3/10 because there's 1 3/10 extra negatives in that problem. And lastly, the one above it, we got negative 4. So here we should get around there. So we're going to put, you have to put the one with the bigger absolute value up top, not necessarily the bigger number. And so 6 goes up top. We're going to take away 2.7. We're going to line up our decimal points, right? We're going to add a 0 there to line everything up. We're going to borrow, bring the decimal down, and we're, instead of getting negative 4, we're going to get negative 3.3. And this is probably the hardest one because some of you may have tried to do it in your head. And whenever you have borrowing in your head, mistakes happen. So be careful of that. You know, you come to the side and do a little subtraction and you're fine. So we're going to review all that today just to make sure everyone's good with this. All right, so we're also going to make sure you understand that there are rules in math. And the rules in math, when a rule always works in math, we give it the name property. And these are 3 properties that you will learn by the end of this lesson. The first one is the inverse property of addition. It says that when you add opposites, they always add up to 0. So do the first problem. Now, when you do my lessons, you do not need to copy that instruction. It's going to say evaluate the expression or simplify the expression thousands of times this year. You do not want to copy that thousands of times. It means find the value, find the answer. What you need to copy down is this problem and then show the answer. On the notes, you need to, many of you like to copy notes exactly. You do not need to do that. If you want to do that, that's fine. But say you already knew the inverse property. You can shorten it, you can use a little code, whatever you want, as long as when I look at your paper, I know you took some notes indicating the inverse property of addition. You can't do nothing. All right, so 1048 plus negative 1048, those are called opposites. They are the same distance from 0 on a number line. All right, they are the same distance from 0 on a number line. That's the definition of an opposite. And when you add opposites, you get 0. So what is negative 4/7 plus 4/7? Well, now it's going to be 0. Let's just, when we do fractions this year, and we're going to have negative fractions this year, the negative sign you can bring right up to the numerator, and it's negative 4 plus positive 4 over 7, which is negative 4 plus positive 4 are opposites. So there's 0/7, and 0/7 is 0. Now you don't have to write all that down, but this is a good hint when you're dealing with negative fractions. Put the negative sign up in the numerator with it. That's totally allowed. So first of all, try to say that problem out loud to yourself. And hopefully you've said one of two things. You can say that as x plus negative x, or you could say x plus the opposite of x, right? That we know that's an addition sign, so it's got to be plus, right? And that's a negative symbol, but it indicates that that's the opposite of whatever x is, right? Because x could be negative 5, and then this one over here would be the opposite of negative 5, positive 5. So that's why saying that as the opposite of x might even be better, but either is correct. And that, no matter for what number you do, that's going to add up to 0. What property says so? The inverse property of addition. You add opposites, you get 0. All right, so if you understand the inverse property, this is easy. So negative 17 plus 17, those are opposites, so they must add up to 0. So then it's 0 plus 3 is 3. Imagine if you don't know the inverse property and you sit there, yeah, you could get the right answer and go negative 17 plus 3 is negative 14, negative 14 plus 17 is 3. Yeah, you get the answer that way, but it's way easier to understand the inverse property and know those are opposites. Right, so if you had opposites, it would add up to 0. So this, therefore, must be positive 5. Again, if you had opposites of negative 17 and 17, that'd be 0. So this has 5 extra negatives, right? 22 minus 17 is 5. There are 5 extra negatives. Here, there's no opposite going on. It's all negative, right? You owe $26 to one person, you owe 28 to another. You could do it in your head, or if you need to, you come over to the side and you realize that there are 54 negatives there. The next property we're going to talk about is the commutative property. There are 2 T's in commutative. Make sure you say it out loud correctly. And so evaluate both of these. So it looks like the same exact problem switched around. In fact, it is. We have negative 4 plus 9. We have 9 plus negative 4. Well, the commutative property says when you're adding, you can switch the problem around and you get the same answer, right? In first grade, you learned that 2 plus 3 always had the same answer as 3 plus 2. Still true with negative numbers. Still true with fractions. It's always true, and because that's always true with adding, then we call it a property, the commutative property. So this one is positive 5. And so I don't even have to do the math over here because I know the commutative property and it's the same thing just switched around. Now, notice this one has these parentheses. The reason those parentheses are there is we don't like to write plus and negative right next to each other like that. We don't like that. That looks weird. Okay, so that's why they're there. But that's why there's no parentheses in the front. That negative sign, and that is a negative sign because there's no number in front. If I put 5 there all of a sudden, then it becomes a minus sign. That's a negative symbol, and so we don't need it there because there's nothing in front of it. Okay, so try these. So we just said negative 4 plus 9 is 5, and 5 plus 1 would be 6, right? Again, because of the commutative property, though, you could add these two together first and do it that way. Now, are these the same three numbers being just in a different order? We have negative 4, we have 1, we have 9. Yeah, all right. So they're the same three numbers being added. Doesn't matter the order. The commutative property says it's got to have the same answer. Third property, the identity property of addition, a property you actually knew long ago. You may have not known the name of it. So please do this problem. Well, negative 217 plus 0 has to be negative 217. You add 0 to a number, it never changes it. It doesn't change its identity. Your identity is who you are, what it is in this case. It doesn't change negative 217. So the opposite of x plus 0 still has to remain the opposite of x, or negative x. So we have three properties. Two start with I. Identity, you add 0, the number stays the same. Inverse, right, you add opposites, you get 0 as an answer. The 0 is over here as the answer. All right, so now we're going to do this with fractions. All right, and these notes are telling the hint I said in the warm-up. When you do fractions, you want to put that negative symbol or sign up in the numerator. So let's see that. Right, what's the rule for adding fractions? All right, you keep the denominator. We're going to put this negative with the 2, and we're going to do negative 2 plus 6. Well, negative 2 plus 6 is 4, and so negative 2 sevenths plus 6 sevenths is positive 4 sevenths. Try this one. So we keep the denominator. We have a 3. We're going to 3 plus negative 8. 3 plus negative 8 is negative 5, and we get negative 5/11. Now notice I left the negative sign up in the numerator. That's totally allowed. But every textbook, when they write the answer, they're going to put the negative sign back out in front. But those are equivalent. There's nothing wrong with either one of them. They're both right. Truthfully, you could even put the negative sign down in the denominator. It would be equal. It is the same number, negative 5/11, but don't do that. No one does that. So try this one. So we have negative 4 plus negative 3 all over 5. So negative 4 plus negative 3 is negative 7. So we get negative 7/5. And that is a correct answer. Now, that's a special type of fraction, which I want everyone to say out loud, which is an improper fraction, right? And there is nothing wrong with improper fractions. We will have a lot of answers this year that are like that are improper. You can leave it that way, as long as it's simplified. What you can't do is leave 8/6, right? Because 8/6 could be simplified down to 4/3. That's no good. 8/6 is no good. 4/3 is fine. Okay, so same thing here. Can you change it? Now, when you change it to a mixed number, right? 5/5 equals 1, right? So this is 1 and 2/5, but you put the negative symbol right there. That's how you write negative 1 and 2/5. Could you even make it a decimal? Sure you could, except the problem was already with fractions, so why would you do that? So either of those is correct, but more importantly for you, you can stop at negative 7/5, and we will many times this year. All right, so at the end of every lesson, there's practice. So there's nothing new. I want you to do these three problems. You can see there are going to be 3 from the squares. All right, and then pause the video and check your work after you're done. So this is, there are extra negatives here. Notice I did it with integers just to show you the answer has to be around -1. And you're going to notice one thing here. Right? I am not a teacher hyper about writing. This is called the leading zero. Now you may have had a teacher last year who was very hyper about you writing that. I am not. Okay, I don't tend to write it myself. So how am I going to make you guys write it? But either way you want to write that -3/10 or -0.3 is fine with me, with the leading zero or not. All right, so there is something wrong with that answer. What is it? Fix it. It is a rule that you always have to simplify your fractions. So 3/12 will never be a right answer in any math class ever. In all situations, you simplify that down to 1/4. That's a proper fraction. Both of them are proper, but this is simplified or reduced, depending on what teacher you had. All right, so let's go over those properties. There were 3 of them. Which one is this? So those are opposites. The opposite of x plus x equals 0. That's an example of the inverse property of addition. You can just write inverse, that's fine. So adding 0 to a number, it stays the same. Right? X and y represent any number. So this is the one that's identity, right? Easy to confuse these two. They both start with I, and they both have 0 in them. But one you're adding opposites, and the other you're adding 0. So which one is that? The opposite of y plus x will always equal x plus the opposite of y. That's always true. What property says so? Commutative, 2 m's and 2 t's in commutative. Thank you.